Hello guys, welcome back to the channel. The paper we are solving today is IGCSE Chemistry, May-June 2024 and this is the paper number 43. Now, let's start with the first question. Name the process used to produce ammonia from nitrogen. So we know that this is Haber process. In this equation you need to remember N2 plus 3H2 giving 2NH3. Name the process which is used to produce lead from molten lead bromide. So this will be done using electrolysis. When you want to extract metals from their ionic compounds, electrolysis will be used. Separate an insoluble solid. Insoluble solid will be separated using simply by filtration. Just think about it. If something is insoluble, you can just filter it out. So filtration. How do you produce ethanol from ethene? We know that in our syllabus there are two methods to produce alcohol. One is fermentation and then the second one is addition reaction with steam, which is also called as hydration reaction. So what you need to mention here is catalytic addition because catalyst is also required in this. So catalytic addition. Alright. Identify the components of a mixture of a soluble colored compounds. Now, fairly obvious answer. Chromatography. Separate a mixture of several liquids with different boiling points. So for this, fractional distillation should be used because it contains a lot of several liquids with different boiling points. So fractional distillation will be better. Determine the volume of an acid required to neutralize. So this is titration reaction. This is what we do in titrations. Now, question number 2. Complete table 2.1. So it's a fairly simple question. Number of electrons, if it is an atom, it will be the same as number of protons, 29. And the number of neutrons will be 63 minus 29, which is 34. Now, next part. Now, this is not an atom, it's an anion, a negative ion. So, protons will not be the same as electrons. Protons will be 17, but since there is a charge of negative 1 and negative means excess of electrons, it's only negative 1, so the electrons will be 18. Now, this you will have to use the periodic table. You just need to find the element with atomic number 30, which is zinc. Now, also look at the number of electrons. If number of electrons are the same as number of protons, charge is same. If it is not, charge will be positive or negative. And if the electrons are less, means it's a metal, so charge will be plus 2. There are 2 less electrons, so deficiency of 2 electrons means a charge of plus 2. Next question. This question is about elements and compounds. Alright. Some properties of graphite, oxygen, carbon are given. Boiling point, melting point is given and conductivity is given. Alright. Explain why graphite conducts electricity when solid. Now, we know that graphite contains mobile electrons. It contains mobile or you can say delocalized electrons in its structure. I'm sure all of you have done the structure of graphite. Carbon has a valency of 4, but in graphite, carbon only creates 3 bonds and 1 electron is free to roam around. Between the layers, this electron keeps on moving and conducts electricity. Now, complete the dot and cross diagram of a molecule of oxygen. Now, just think about it. Molecule of oxygen. Oxygen is a diatomic molecule. And if you look at oxygen atom, it's in group 6. So, the valence electrons will be 6. Atomic number is 8. So, 2, 6 and the other oxygen atom will also be 2, 6. Now, we know that stability is achieved by octet rule. So, both of them need to share 2 electron each, right? Then it will become an octet. So what you need to first of all show is draw 6 valence electrons. 1, 2, 3, 4 and 5th electron here and its 6th electron here. Alright. Now, yes. Now the other electrons 1, 2, 3, 4 and 5th electron here, 6th electron here. In this way, what you are telling us is that Now this oxygen contains these many electrons. These two are shared between each other. These two electrons are shared between each other. So now this is your stable structure. Deduce the physical state of carbon monoxide at negative 195 degrees Celsius. Let's look at the table. See, carbon monoxide is melting, means it is converting from solid to liquid at negative 199. Then it is boiling at negative 191. So it is converting from liquid to gas between 199. And negative 195 is in between, so it must be a liquid then, right? So the physical state is liquid. Now, next part, explain how did you figure this out? You can just clearly mention that the melting point is below 95. Melting point is below negative 195 degrees Celsius and above negative, and the boiling point is above negative 195 degrees Celsius. So liquid lies in between. All right. Now for this question, I've written the answer. Explain in terms of structure and bonding why graphite has a much higher melting point than carbon monoxide. See, it's a fairly simple logic that graphite is a giant covalent structure. It is a giant network. But on the other hand, carbon monoxide, it is a simple covalent structure. So what I've written here is graphite has a giant covalent structure. CO, carbon monoxide, is simple covalent. So there are strong forces of attraction between particles in graphite, but there are weaker forces of attraction in carbon monoxide. This is the answer. Now, part B, potassium reacts with chlorine to form potassium chloride. Write a symbol equation. See, potassium is K, chlorine is a diatomic molecule, so we will write Cl2 here. Now, as a result, they will form KCl, but you need to balance the equation. So, a 2 here and a 2 here, and this will get you the marks. Now, a dilute aqueous solution of potassium chloride undergoes electrolysis. Oxygen is produced at anode. State what is meant by the term electrolysis. It's a fairly simple definition. Just think about it. Lysis means break. It's a word in bio. You just need to understand lysis means in order to split or break something. And electro means by usage of electricity. So it simply means when you are trying to break a compound by passing electricity through it, right? So what I have written here is breakdown of an ionic compound by passing electricity through it in molten or aqueous state. Why is this important? Because ions are only present in molten or aqueous state. Ions are not present in solid state. And when you're thinking of passing electricity, it should be a conductor, right? So that is why ionic compound, not a covalent compound. Now, write an ionic half equation for the production of oxygen at anode. Now, this is one of the equations which you need to remember for your IGCSE syllabus. So, I'll just write down the equation here. 4OH negative is equals to O2 plus 2H2O plus 4 electrons. Keep this in mind. Sometimes in exam papers they ask you what is the product at anode. Now according to this equation we think that oxygen is also formed here, water is also formed here, then both can be the products. It's not. Water is in dissolved form in the electrolyte, so it is very difficult to identify water. The observable product is oxygen only. All right. Now question number 4. Dinitrogen tetroxide decomposes into nitrogen dioxide. Reaction is reversible. All right. Figure 4.1 shows a gas syringe containing a mixture of these two compounds. The gas syringe is sealed. The mixture reaches equilibrium and the color of the mixture of the gases is pale brown. Okay. Describe a reversible reaction at equilibrium in terms of rate of forward. See, you just need to explain in terms of forward and backward reaction. Is it equal, unequal? One is larger, the other one is smaller. How does it work? This is what you need to explain here. So you just need to mention rate of forward reaction is equal to rate of backward reaction. I am writing in short form, but you should not just clearly mention rate of forward is equal to rate of backward. Do not be lazy like me. The concentration of reactants and products. So it is clearly given in your syllabus guide that the concentration of reactants and products should be constant. So this is what you need to write here. Now, pressure of the mixture is increased. All the conditions stays the same. The mixture immediately turns darker brown before the position of equilibrium changes. Explain in terms of particles why mixture immediately turns darker brown. So in short, they're just asking you that when we are increasing the pressure, the color of the solution is changing to darker brown. Now let's have a look at the equation. So there is 1 mole of gas on the reactant and 2 moles of gas on the product. We know that when pressure is increased, equilibrium shifts to the side with less gaseous molecules. And when it is decreased, it shifts to the side with more gaseous molecules. Alright, now let's look at the question again. Explain in terms of particles why mixture immediately turns darker brown. So for this, what you can mention is that as you are increasing the pressure, so there are more number of molecules per unit volume. You have to answer in terms of particles, you do not have to answer in terms of forward or backward reaction. In terms of particles, we had to answer, this is why I'm writing more number of molecules per unit volume are there. So greater collisions are there, meaning there will be darker brown color. Now, the temperature of the mixture is increased, all the other conditions stay the same, the mixture turns darker brown, state what can be deduced about the forward reaction. Now, there can be a lot of answers for this question, but you have to specifically answer in response to this data given. They're telling you that when I'm increasing the temperature, then darker brown color is obtained. And also in B part, in case you are confused that why did we not answer in response to equilibrium, forward or backward reaction, look at the statement here. They are saying the mixture immediately turns darker brown before the equilibrium changes. So we cannot apply the logic of equilibrium here. They're clearly telling you do not apply the logic of equilibrium here, just answer in terms of particles. But now in C part, you have to answer in terms of equilibrium. The mixture turns darker brown. So let's have a look. Where is darker brown present? So in the equations, darker brown gas is present on the product side. It's present on the product side. So we can get the data from this that when you're increasing the temperature, forward reaction is increasing. Is increasing. I think this is what the option statement C is telling us, question C is telling us, that when you increase the temperature, brown gas is obtained, means forward reaction is preferred. Now you just need to check whether endothermic prefers forward when temperature is increased or exothermic. We all know it is endothermic reaction. In endothermic reaction, when you increase the temperature, forward reaction is preferred. As a result, darker brown color is obtained. All right, now next question. So again, this is an equilibrium question, and on the reactant side, there are 3 gaseous molecules, and here there are 2 gaseous molecules. They're just asking us that if you add a catalyst, what will be the effect on rate of forward reaction? Now, when you add a catalyst, rate of forward reaction and rate of backward reaction both increase. Some students might be a bit confused about this, that our teacher has told us that a catalyst does not affect equilibrium. It is true. Catalyst does not affect equilibrium because what it does is it increases the rate of forward as well as rate of backward reaction, which nullifies the effect. If you're increasing same in both directions, it cancels out. It's just like physics. 5 Newton here, 5 Newton here, cancels out. And if it is 10 Newton here, 10 Newton here, again cancels out. But the question is not asking that to you. They're only asking what is the effect on forward reaction. The answer should be increase. Alright, if they were asking effect on equilibrium, the answer will be no change. Just like they're asking here, effect on equilibrium yield, no change. Increase the pressure, what happens to the forward reaction? Now, When we increase the pressure, equilibrium shifts to the side with less gaseous molecules. Now, in this reaction, you can clearly see that product side there are less gaseous molecules. So, on the forward reaction, there are less gaseous molecules. So, this will increase. What happens to the equilibrium yield of SO3? Now, just think about it. If you're going to the forward reaction and forward SO3 is already present there, so it will increase. Deduce the oxidation numbers of sulfur in S. See, sulfur in elemental form is always the oxidation state 0. So just mention 0. In SO3, how do you figure it out? Take sulfur as X, oxygen as 3 times negative 2. Why I'm taking negative 2? Because single oxygen has a charge of negative 2. And total charge is equals to 0. So X is equals to positive 6. You need to mention positive 6 here. Question number 5. Barium sulfate is an insoluble salt and it is made by precipitation. Now, for precipitation, you need to remember it is made by two soluble salts, soluble salt 1, soluble salt 2. Alright, and we know that span salts are soluble, sodium, potassium, ammonium, nitrate salts are soluble. Now, you just need to figure out how can you obtain barium sulfate. So, first thing, we can obtain barium from barium nitrate because all nitrates are soluble, so you can use barium nitrate. Use the simpler one. Then we also need to obtain sulfate somehow. So you can use sodium sulfate because all sodium salts are soluble. So just use sodium sulfate. So write barium nitrate here and sodium sulfate here. Describe how to produce a pure sample of barium sulfate from the mixture of aqueous solutions in A part 1. So they're just asking you that when you use both of the salts, then you have insoluble salt. How do you obtain it in pure form without any impurities? So first what you do is you filter it. Second, you wash the residue with water because sometimes what happens is little soluble particles stay there. So you wash it with water and then you can just mention dry between filter papers. Alright, write an ionic equation for the precipitation reaction which produces barium sulfate. Now all of you might be confused in this that they have only given little bit space and it is for 3 marks. So what do we need to mention? You need to give only one equation here and I will give you a short trick here, but you need to have knowledge of ions. See, the compound you want to produce is barium sulfate, right? And it's a precipitate, so you just write barium sulfate in solid form. Now, what I want all of you to think is that barium sulfate will be made from which ions? Which ions is it made from? As it looks, it is made from barium ion, which is a charge of 2 plus, and it is made from sulfate ion, which is a charge of negative 2. And just write aqueous here. You will get 3 marks for this. You need to mention the state symbol, the ions, and the correct product. Alright. Now, in case anyone is thinking that we have not done this method, we have done some other method, I'll also show that method to you. You might have done this method that barium nitrate plus sodium sulfate giving barium sulfate plus sodium nitrate. Then your teacher might have taught you that you cancel out the spectator ions. Spectator ions are the ones which are exactly same on both sides, but you cannot cancel out ions from solid precipitate. All right. So we see that nitrate can be cancelled out here, and sodium can also be cancelled out here. Sulfate and barium you cannot cancel out because now in the product side it is solid. So again you get the same logic. Ba2 plus SO4 2 negative is equals to BaSO4. Both will get you the same answer. The one which I told you earlier is the simplest one and the fastest one. You just need to think about the ions the precipitate is made from and then write it down and you get the marks. Now let me erase this. Now, soluble salts are made from dilute acids. Name the dilute acid and one other substance that react together to make copper sulfate. So you can use a sulfuric acid for the sulfate part, and they are mentioning acid, so that is why sulfuric acid. Now, other substance you can do it by the excess method, that is the copper oxide, or also just make sure to mention the oxidation state. So just write it down like this: copper 2 oxide. Now, nitrates decompose when they are heated. When hydrated copper nitrate is heated, oxygen gas is produced. Describe a test for oxygen. The test for oxygen is a glowing splint. And what is the observation? It relights the glowing splint. Now, part two, you have to balance this equation. So, first of all, I think this will be the only section where most of you will be confused. So, let me make it simpler for you. This is the compound. This is the total compound. Now, this is times 2. Just think about it. You will have 2 copper atoms and nitrogen atoms. Here it is times 2, then again times 2. So, 4 nitrogen atoms. Oxygen, it is 3 already, but this is times 2, which is 6. But again times 2, which is 12 oxygen. Plus, there is also some oxygen present here. It is 3 oxygen here, but again times 2, so 6 oxygen as well. Then hydrogen, there is 6 hydrogen here, but times 2, so 12 hydrogen atoms. All right. So you have 18 oxygen atoms, 4 nitrogen atoms, 2 copper atoms, and 12 hydrogen atoms. Now, first of all, we can balance the hydrogen. So 12 hydrogen atoms are there, and there is H2O, so you need to put a 6 here. Now, when you look at the copper, you have 2 copper atoms, so you need to put a 2 here. Nitrogen should be 4, so you would put a 4 here. When you do this, now you count the number of atoms which are balanced, your answer will come out to be correctly. 2COO plus 4NO2 plus 6H2. Alright. Now, this is a stoichiometry question. Hydrated zinc sulfate gives off this much, alright. A student does an experiment to determine value of X. The student weighs it and he heats it. The student weighs the solid after heating. The student repeats step 2 and step 3 until the mass is constant. Solid after heating is constant. So this is done just to make sure all the water has been evaporated. So to ensure all water is given off. Alright. Now, in an experiment, 0.74574 grams of this much is heated until the mass is constant. The mass of ZnSO4 that remains is 0.322 grams. So they're telling you that the hydrated compound has this much mass, but the anhydrous form of it contains this much mass. So what is the mass of water? Mass of water will be 0.574 minus 0.322, and we will solve this later on. Determine the value of X using the following steps. So we have to follow through the steps, and in the final step, we have to find what is the number of moles of ZnSO, what is the value of X. Now first, calculate the number of moles of ZnSO4. So you know that the mass is 0.32 and the molecular mass must also be given here, Mr, which is 161. So you divide both of them, 0.322 0.322 by 161, your answer will come out to be 0.002. Calculate the mass of H2O given off. So you just need to subtract both of them. Your answer will come out to be 0.252. So write 0.252 here. Calculate the number of moles of H2O. Now you know that it is 0.252 by 18. The molecular mass of H2O is 18. So divided by that, you will get the answer to be 0.014. The most important step, we have to figure out the value of X. Now for this, we need to understand that what is the ratio between X and zinc sulfate. You need to know the ratio between zinc sulfate and X, and you can see here in the equation, the ratio is 1 is to X, right? So let's write it down here. Zinc sulfate and H2O, the ratio is 1 is to X. And what are the original moles of zinc sulfate? 0.02, 0.002. And what are the original moles of H2O? It is 0.014. Now it's just basic maths. You can cross multiply or you can just divide 0.002 by 0.014 to get the value of x. It will come out to be 7. Alright, I hope you're getting this point. So the answer will be 7. Now, question number 6, it's a blast furnace. Extraction of iron is taking place here. Name the main ore. We know that it is hematite. Name the substance that enters the blast furnace at A. We know that air enters at A, so you just need to mention air here. Name the reducing agent. Carbon monoxide is the reducing agent in this question. There is also an equation for it, that Fe2O3 plus carbon monoxide gives Fe plus CO2. So carbon monoxide is a reducing agent. This equation is not balanced. Make sure to balance it. Now, explain why limestone is added to the blast furnace. See, what happens is limestone is calcium carbonate. So first of all, it thermally decomposes to form calcium oxide plus CO2. Then what happens is this CaO reacts with the silicon dioxide present and it forms CaSiO3, which is called as calcium silicate, and the common name is slag. So this is what you need to write here. Calcium carbonate thermally decomposes to form CaO plus CO2. Calcium oxide reacts with SiO2, which is silicon oxide, to form CaSiO3, that is calcium silicate, which is slag, and you will get 3 out of 3. Now, the list shows the properties of some elements, so it's regarding periodic table. State which property from the list is true for sodium but not iron. Alright, which property is true for sodium but not iron? Sodium, does it act as a catalyst? No. Does sodium have a low density? I think so. Sodium has low density but iron does not. So your answer should be have low density. Have low melting point. Sodium has a low melting point but iron does not. So you can write anyone out of these two. Have low melting point. Now, which property is true for iron but not sodium? True for iron but not sodium. So we can directly pick form colored compounds here or catalyst, because we know that transition metals have both of these properties but group 1 metals do not. So you can pick anyone out of these two for part 2. Is true for sodium and iron. Now we have to pick a common property which metals share. And we know that metals form basic oxides. Right? Metals form basic oxides and they form positive ions. So you can pick this one or this one. And do not mention acetic oxide, mention basic oxide. They form basic oxides, or you can say they form positive ions. Alright, it is not true for sodium and also not true for iron. So we have to pick a property which is not a metallic property. So they form basic oxides, but they cannot form acidic oxides. Acidic oxides are formed by non-metals. Now, next question. Steel consists mainly of iron. Iron rust when it is reacting with water and oxygen. Alright, sacrificial protection setup is given to us. Explain in terms of electrons why magnesium is used for sacrificial protection. See, what you need to understand here is, in sacrificial protection, we use a metal which is more reactive. Why are we using it as more reactive form? Because if it is more reactive, it will react with the moisture, water, oxygen present nearby, hence saving the metal you are trying to protect, right? So what you need to mention is that the magnesium, being more reactive, readily reacts and loses electrons. It is more reactive than iron, so it will loses electrons and gets oxidized first. Loss of electrons is oxidation, so this is what you can mention here. Name a metal that cannot provide sacrificial protection of steel. So any metal which is less reactive than steel. You can mention copper, silver, gold. Alright. See, the whole idea is, if you want to protect something, you coat it with something more reactive. But if you're coating it with something less reactive, what is the benefit? Question number 7, organic compound is given. It's a stoichiometry question. Percentage is given and you have to find the empirical formula. So what we need to do here is carbon, hydrogen, percentage is 83.3. We take it as grams because the percentage is adding up to be 100 grams, right? 100%. So you just directly take it in grams, divide by the atomic mass. Let me use the calculator here. Give me 1 minute. So when you divide 83.33 by 12, it comes out to be 6.94 and this will be 16.67. Now the next step is divide by the smallest number of moles. So this divided by itself will be 1 and 16.67 divided by 6.94 will be 2.4. Now, what do we do here? Is there a common ratio here? If you multiply both of them with 2, it will become 2 and this will become 4.8. This will not work out. So if you multiply it by 3, will it work out? No. You just need to keep on checking the ratio. And according to basic maths, if you multiply this by, just a minute, 12. Yes, if you multiply by 5, it will exactly come out in whole number. So it will be C5H12. Alright, you just do hit and trial, multiply with 1. If the directly decimal is coming, that it is not right. Then when I multiplied with 5, whole number is coming for hydrogen, then this is the answer. Alright, now compound B has the empirical formula this much. Relative molecular mass is this much. Now just think about it. There is a compound B whose empirical formula is C2H5. So let's first of all find the mass of empirical formula. It will be 2 times 12 plus 5 times 1, which is 24 plus 5, which is 29. Now, what is the mass of molecular formula? 58. Now, just think about it. Is there a direct relation between them? I think it is times 2 only, right? So, you just multiply the empirical formula with 2 and this is your molecular formula. Alright, in these kind of questions, you just need to check the ratio between the empirical formula mass and the molecular formula mass. Whatever ratio you get, you multiply the empirical formula with that one. Now, this is an organic chemistry question. Figure 7.1 shows a section of a polymer formed an alkene, formed from an alkene. Identify the functional group in alkenes that reacts. Functional group. What is a functional group in alkenes? Double bond. So you just mentioned carbon, double bond, carbon. Now, a section of addition polymer is shown in figure 7.1. Draw the displayed formula of the monomer that forms this polymer. Now, this might be a little bit tricky for some of the students, but pay attention here. I'll explain it in the simplest words. Now, first of all, in order to draw the monomer, you take 1 unit. Take 1 unit and break these extensions, make a double bond here. So let me write it here. Carbon double bond carbon, C2H5 and H and H and another H here. Alright, this is a monomer. We know that in monomers, double bond must be there. When you split it, then a polymer is formed. Now we are doing it the other way. So it is reverse engineering. You have the product, you are creating the reactant now. Alright, so now you make the double bond. Now, is this the answer? No, we need to write it in displayed form. So what you should do is put the double bond carbon first, then one hydrogen here, one hydrogen here. Now, on this carbon, you know that C2H5 is present, right? C2H5 is present. And what is C2H5? It is CH3 and CH2, right? So what you can do is you can just write CH2 here, then CH3 here, and this carbon also had one hydrogen, so you put 1. Alright, now let me explain this again. What I did here is that the polymer was given to us, so you pick a unit, repeating unit, and then you create the double bond in between. Now, then the structure starts looking like this. This is 1 unit, that is correct, but you have to draw the displayed formula. In displayed formula, you have to show all the bonds. Then what we simply did is, instead of C2H5, we wrote it in the form of CH3CH2 and the answer you have here. Now name the monomer used to form this polymer. So you just need to name this And according to the naming convention, 4 carbon atoms are there. So it is but, and there is a double bond on the first carbon atom. So you can mention but 1 dash ene. 1 is representing the position of double bond. Alkenes are produced by cracking alkanes, all right. They have given an alkane that they're cracking. The products are ethene and an alkane, which form in 2:1 ratio. So what this is telling you is that the ratio should be 2 and 1 here, and ethene you have here. We know that ethene is C2H4. All right. Now it's just simple maths. Just think about it. C12H26 you have here, and this is giving you C4H8. You do not have to write it in this form, but now I'm just counting to get the other product. So just understand. So what will be remaining? 12 carbon here, 4 carbon here. Remaining is 8. 26 hydrogen here, 8 hydrogen here. Remaining will be 26 minus 8, which is 18. So your answer will be C8H18. This is the answer. Alright. Now state the general formula for alcohol. So it is CnH2n plus 1 OH. Draw the displayed formula of one alcohol with the molecular formula C3H8O. So the molecular formula is C3H8O. Now I'm a little bit confused with this, but let's do one thing. I will try drawing propanol because this is a 3 carbon only. So let's give it a try. I will try drawing propanol. So 3 carbons, and you put one OH here. Rest just put the hydrogens. Now let's check the molecular formula. C3, 1, 2, 3, 4, 5, 6, 7, 8. 8 hydrogens and 1 oxygen. Oh, so the answer is correct. See, if you're confused about this, you just had to give it a try. Carbon 3, so I tried drawing this and you get the answer. Now they're asking you the name of the alcohol. You can call it propane 1-ol. Because alcohol is on the first carbon, so you mentioned propane 1-ol. Any more questions? No. So we are done with the paper. In case of any doubts, feel free to let me know in the comments section.